So here we're going to take numbers that are written in standard form and we're going to convert them into scientific notation. So this is definitely more challenging than going from scientific notation into standard form for a couple of different reasons. And one of the main pieces is because the sign does not necessarily match up how you would actually do this. So we'll talk about that more in just a moment. But the general idea is that we're going to move the decimal point to the right of the leading non-zero digit so that we only have one non-zero number before our decimal. That's going to ensure that our number is between 1 and 10. And then we're going to count the number of places that we had to move the decimal point. That'll indicate the exponent of the power of 10. Now, it's important to recognize and remember that large numbers, big numbers, will have positive exponents, and the really small numbers between 0 and 1 are going to have negative exponents. Again, this isn't always intuitive as far as the direction that you're moving because depending on how you do these, you may move the opposite direction. So it's more important to recognize these different components, that a number that is big, larger, greater than or equal to 10 is going to have a positive exponent, and the number that is between 0 and 1, the really small numbers, those are going to be negative exponents. Let's take a look at some examples. All right, so the first one we have 50,000. So again, our first goal is to place the decimal directly after the first non-zero digit. So we go from left to right. We have 5. That's our first non-zero digit. So our decimal we know is going to go right after that 5. So we know, and it's 5.0, which is just 5. So we know as part of our scientific notation, we're going to have 5 times 10 to some power. With scientific notation, we always have something times 10 to some power. That's standard form, that's standard notation. So we're going to be moving our decimal. In this case, we find how many places we move to the end. 1, 2, 3, 4 places to the right. Now again, the direction doesn't always match the sign of the exponent, but 50,000 is a large number. It's bigger than 10. So we know that our exponent needs to be positive. We see we moved our decimal 4 places. So 5 times 10 to the 4th would be that number written in scientific notation. The next example, we're going to place the decimal again after our first non-zero number, non-zero digit. So it's going to be after the 2, between the 2 and the 5. It's important to recognize that if we place it anywhere else, our number will not be correctly written in scientific notation because the first value has to be between 1 and 10. If I were to place it before the 2, 0.25 is smaller than 1. If I place it after the 5, I have 25, which is larger than 10. We have to ensure that this number is between 1 and 10. So the way that we do that is we put the decimal after the first non-zero number. All right, so we see we have 2.5. We don't need all those trailing zeros after the decimal. So 2.5 is all we need there, and then we know it's going to be times 10 to some power. We look at how many places we move our decimal. In this case, 1, 2, 3, 4, 5, 6, 7 places. We know that since this is a large number, our exponent will be positive. So 2.5 times 10 to the 7th power will be that number written in scientific notation. Number 3, not a really large number, and this is the type of number that we wouldn't typically write into scientific notation, but we have to make sure, of course, that we understand how it would be written in scientific notation. So the decimal is going to come after the first non-zero number, which would be after the 6. So here we have 6.83. We do need all digits because we don't have any zeros there at the end that we can kind of ignore. We know that it's going to be times 10 to a power. We see that our decimal would have to move 2 places to get to the end or where it was originally. So we know our exponent in this case would be a positive 2. Now this isn't a super large number, but it is greater than 10. So we have to make sure that we have a positive 2 as our exponent there. Moving on down to number 4. So again, decimal goes after our first non-zero number. So going left to right, we have 0, 0, 0, 0. Then we have a 5. So the decimal is going to go after that 5. So we know that we have 5.0 or just 5 as our factor here, times 10 to some power. We look at how many places our decimal moves. 1, 2, 3 places. Now here's the key. We see that this is a small number. It is between 0 and 1, so we know our exponent has to be negative. So 5 times 10 to the negative 3rd power would be that number in scientific notation. Next example, decimal is going to go after the first 3, so in between the two 3's. So here we have 3.3 times 10 to some power. Let's count how many places to figure that out. 1, 2, 3, 4, 5, 6, 7 places. It is a small number, so we know our exponent has to be negative. 3.3 times 10 to the negative 7th is that number written in scientific notation. Now again, I do want to reiterate that we cannot just count the number of zeros. So don't look at a number, count the number of zeros, and then put that as the exponent. It will not always be the case. We see that happen more often with the small numbers, with the decimals, but we really just have to be careful and make sure that we're counting the number of places to make sure that our exponent is correct. Also, a lot of these numbers are too big for some of the calculators that we use, even too big for Desmos. So you may not always be able to type it in and see if it's actually equivalent to the decimal form or the standard form. So you don't always have that check to be able to see if it's correct. So you have to make sure that you work through these carefully. All right, last example here, or second to last example, decimal is going to come after the 5. So 5.06 times 10 to some power. So that we see we're moving 1, 2, 3, 4 places. So since this is a small number between 0 and 1, 5.06 times 10 to the negative 4th will be that number in scientific notation. Let's take a look at number 7. So in 2017, Amazon bought Whole Foods for, 15.3, and there is an extra 0 in there. That's not supposed to be there. $15.3 billion. So Amazon bought Whole Foods for $15.3 billion. We want to write this amount in scientific notation. So decimal is going to go after our first non-zero digit, which is after that 1. We have 1.53. All of the numbers after are zeros, so we can eliminate those trailing zeros. 1.53 times 10 to the... Let's count how many places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a large number, so obviously our exponent is going to be positive. 1.53 times 10 to the 10th power. That is $15.3 billion written in scientific notation.